Good evening, Twitch, or good morning or good afternoon. Who knows what time zone you're in? Welcome to yet another Netflix data stream. Maybe that's somewhat misleading. I should probably clarify that. But first, I have to say a huge thank you to White Panther for the shout out and lovely comments in her stream. So if you are coming over from her stream, much appreciated. Also appreciate all the follows. And for people who are interested in what I'm doing. Today, we are going to be continuing with the Netflix data that we looked at last stream. And so for framing, let me just change over here. So last time I explained that I did a GDPR request to Netflix asking them for a copy of our, meaning me and my partner's, Netflix Behaviour. And of course they obliged because they're lovely individuals over at Netflix. They even have a wonderful process where you can do this. And yeah, we got a copy of our data. Unfortunately, we didn't get very far in terms of data analysis because we spent a lot of time trying to figure out how to work with JSON event data. Meaning that there were some rows, or one table in particular that had JSON data as part of like a sequence of events. And we had to find a way to work with that. So we spent some time on stream trying out various things. Me, trying and failing for many hours. Even after the stream, I could not get things to work properly. However, I have figured it out since, and I'm happy to show you the solution. It's not fully finalized either, which is nice because we can work on it a little bit more in the stream as well. But today we can get into these lovely questions. Seeing as it is our data, meaning my partner and I have asked her for consent as well to do this on stream, and she's more than happy to oblige. I did give her a choice, just to be fair. And so I have the get-go. That being said, small disclaimer, I did take some things out during last stream. You can go back and watch the VOD. It will also be up on YouTube soon. So here on Twitch, it's still available. I took out some things for privacy, like our search history, which I feel is sort of crossing the line of what is personal and what's not. So do let me know if you're here in chat watching. Would love to know where you're watching from, what kind of things you're interested in, why you're here. Feel free to ask questions at any time. This is an open learning environment where everybody is welcome, from all ages, shapes, forms, beliefs, doesn't matter. We're here to learn together. I am also on a learning journey, and I want to share that with you. So, I thought of a few questions that could be interesting to explore once we get to the point where we've actually finished this JSON data parsing stuff. The first one is like about watch time. Like, is our watch time together different, like longer or shorter than when we watch separately on our own accounts? For reference, we have 3 Netflix profiles. We also have a 4th one for our bunny rabbits, but they don't use it very often. Basically, 1 profile for each of us, and then 1 roll-up profile for when we watch things together in order to have the recommendations streamlined. My hypothesis here is we watch longer when we're together. I don't know if this is true or not. It's just something I think is true. Do we watch more TV versus movies? My hypothesis is we watch more in terms of TV shows, as in number of titles, and in terms of watch time. That's a pretty easy one to answer, to be honest. Also, are there any common shows that we watch separately that we could actually be watching together? So that could be a funny one, where actually we've been watching maybe the same show or movie separately, but actually we could have been watching it together. So that could be pretty funny. Yeah. So I think it's time to jump straight into the into the thing, right? Into, data grip, basically. So in case someone would ask, this is data grip. Data grip is a IDE for accessing databases. It's very, very helpful when working with databases and just data in general. It's one of the best, in my opinion, for doing that. And yeah, I've been working with data grip on stream for a while, so. Sorry about that, just second device problems. So yeah, JSON data. So without looking at the actual solution yet, maybe we should look at what we were doing last time. And basically there's this play traces table, or playback events table, which has a play traces column in it. And this play traces is really interesting because it's basically, in terms of structure, it's a array of JSON items, JSON formatted items in the array. And this is a really, really smart way to save data in a very consolidated way, because, especially web data, because it has a lot of context information, but at the same time, it also enables us to collect a lot of basically key value pairs in a formatted way without worrying about whether every single one of these play traces has the exact same notation. Algebra asks, can we use non-structured database for that JSON array? You absolutely can. The downside is that I'm using Postgres. Postgres is a structured database, and so I needed to find a way to separate this out. The classic solution would be, as you said, using something like maybe MongoDB or Cassandra or something that's unstructured. That being said, there isn't really a problem per se in using a structured database type like Postgres or MySQL. It just means it's a little bit more tricky to work with. What do I mean by tricky? Basically, one line here has potentially 200, 300, 400 items in this array, which means that this one line will result in at least 400 rows after splitting this out. And if we would actually split out everything individually, it may be more than that, depending on how we split it. So let me take you through with what we were working with last time. Basically what we did is we selected the playback events. So this is the play traces table. I just truncated a couple of the columns we don't need. We can always do this later again, but basically, feed it back into itself, right? We have a playback event ID. We have a timestamp, which is in UTC, which I love. It's already UTC formatted. We don't have to worry about what time zone this stuff was in. And we have this play traces JSON. I've converted this to JSON. When I imported it, I just imported it as text, which, well, you know, when you import stuff, you don't always think about that. So, that being said, I don't think there's any issue here. And what I did is I made sure that the length of the play traces was larger than 2. Which unfortunately doesn't avoid getting rid of these brackets, which I actually wanted to do now, because I actually don't want these to appear. There we go. So I'm not sure, maybe there's like an empty field or something stopping these from appearing. Oh, that's weird. Wow. Oh, thank you for the follow, Indigenous Navi. Much appreciated. Maybe I didn't actually execute with the where condition before. Okay, now this is right. So we basically have every array item here. And the thing is that I don't want it to start with everything. I want to do ones that are a little bit more straightforward. But what I did is I started with saying, okay, we have this playback event ID. We have a timestamp and we have a JSON, and I'd like to insert for each array itself, I would actually like to have an identifier, basically saying this is the first array, second array, third array. So I did that. That actually looks like this. You can just do a in-between query, if you will. And this actually looks like that. So I have an event ID, and then I have the array. And of course, the array hasn't been split out yet. So these follow the same logic. And you'll see why I'm doing this in a moment. So that was that. Then we went onwards and said, okay, let's split everything else out into, let's split them into individual rows. And the way that I did that was using my aptly named JSON, basically using this function called JSON array elements, which splits out each individual array item that is JSON into itself. So let me show you what that looks like, because it's very hard to explain without visualizing it. Or I find it pretty bit tricky to explain. So this is from JSON. This is actually what it looks like. So you see here this, and do let me know if the font's a bit small. I can make it a bit bigger here. So you have this playback event ID, and you'll notice these rows here are basically the 5 or 6 different array items that are attached to this one event. And so this one event had these different attributes attached to it with this playback start timestamp. And so basically we have now reached the point where we could take each of these individual rows and split them out again into the key value notation that we have in these JSON. And that's what this special function does, called JSON each text, or JSON each. And this is where I got really bugged on Monday, because if you actually use JSON each text within the select, it doesn't actually break it out into the individual rows. And the reason for that, as far as I understood, do correct me if I'm explaining this wrong, if someone does know better. The reason for that was that JSON each text requires it to be within the from statement so that it can split out the data while joining it to the original object itself, or rather to the array that it actually belongs to. And I can actually maybe show you the difference. So if I execute this the way that it is, this is now our first playback event, which had originally 6 rows. It now has a lot more. Oh, sorry, these all have the same timestamp? Really? Oh, here it was. Here. So it now has 18 rows. And the reason it has 18 rows is because each of these key value pairs have been split out. And this is where it's not quite finished yet, because the event array IDs are all the same here, and I need them to be different. I need them to be 1, 2, 3, 4, so that I know the sequence of these particular key value pairs together within the actual playback event itself. And we will correct that today. I have an idea of how to do this. So if I do it the other way, and ignore my alias because I was very frustrated. You can use your imagination as to what this actually means. If I do it the other way, where I actually just use JSON each text here within the select, but not within the from statement, what happens is the following. It splits them out, but it doesn't break them up into their key value. It keeps them nested. It keeps them in these pairs. And so actually doing it this way allows me to, I have the same number of rows, but I have already the split. So I don't need to do here, like, I don't know, split something or whatever. It's a very elegant solution. And I'm very happy that this function exists. Really, like, very, very happy. Because, as I said last time in the stream, there are some play traces that are over 300 long. Like, really, there's some that are over 300 long. And so if we consider that we would normally, so this is like 300 long, you won't see it, it just goes off screen, right? If this playback event is over 300 long, then I have no chance to program or to actually type out each of these individual, each of these individual array items. Like, I need to do it programmatically, right? And so you see here, actually, there's quite a few of these that are really, really big. And that's fine, it's not an issue. I don't actually remember what the biggest one was. We might need to do, here we go. Now we're starting getting somewhere. So there's some that are like 5,000. Oh, look at that. There's some that are even over 10,000, which is pretty crazy. So basically, the smart thing to do is to do it programmatically. And say, okay, any of these playback events, they are, like, as long as it has more than one item in it, or one item or more, then I want to do it programmatically where I split it out. Now, that being said, we have an issue, and that issue is with this playback event array ID. So before we feed this back, before we go making some kind of ID that we can use, if you created a table, we would have a serial, but we don't have that function. We can just use row number instead. The issue is that the row number is applied after the aggregate. So basically applying row number here and then using JSON parsing kind of within here, and then within here again, within this last part of the common table expressions, basically means that it's executing these at the same time, which is why they are receiving the same ID, the same number. And so actually the solution is to execute these at alternate times. So I was thinking about basically having row number over be executed further down here, which is my playback event array ID. I'm just going to comment it out here so we can see if this works. So you see now this works fine. 1, 2, 3, 4, 5, 6, 7, etc. And I have a playback event ID, which is being generated from up here from the row number. And I'm doing this purposely from the order by, making sure that I'm taking the oldest event at the top. And we can test this out to see if this works, but I think this should work fine. The one thing I need to do is partition it, because right now it's applying this to the entire data set. And what I need it to do is restart from 1 again when it reaches this row here. And the way that I do that is apply the partition here. Partition by, so in this window function in over, I can just apply partition by playback start TSUTC, because they all have the same denotation. Or we can even do it cleaner. We can actually do it with the event ID itself. There we go. We've solved the problem. It seems like. Yep. So this one has 12. This one has 12. This one has 12. Wonderful. This one has 24. Great. So algebra asks, partition by is like group by, right? But more like an inside version of group by. Yes, in a way. I mean, if I wanted to make an analogy, let's say you have your entire data set with AAAA. Oh, autocompletion is going to get the best of me here. And then you have BBBB, and you have CCCC. This is your entire data frame. When you do some kind of aggregate, and you say, okay, aggregate these 3 metrics here, or let's make it more realistic by putting these like here, 1, 1. Let's say that this is some kind of metric, 1, 1, 1. When you say, give me the sum of these 3 rows and group by this column, then it can only do 1, 1, 1. That's fine. But when you do this function, and at the same time, you also want to aggregate something within that frame, but split it by each of these individual elements. So basically, if you had something like this, so everything is, let's say 5, 3, and 1. So if you did a sum of all of these, you would get basically, let's make it more easy to understand. If you did a sum with a group by, you would have 9 would be your group by A, right? But you could at the same time also do a window with this over. That's basically this window functionality. You could have an over and say, okay, I want to have the sum of partition by A, B, and C, so column 2. And you could say in the same query, it allows you to do both. So you could group by A, but also have A5, B3, and C1 within the same end result. The example I saw for this one was, for example, an exercise I did earlier today with some colleagues at work, where we were looking at fuel stops with a data set where every fuel stop was recorded from different days. And fuel stops occurred over multiple years, and you want to know maybe how different is the time between fuel stops, but not only within that month that you're looking at, but within the entire data set. So what you can do is just have the entire data set like you have here, and you can actually then say, I want to take the average of the entire data set. So it gives you, as you said, it gives you a kind of way to create a window on your data. So if you consider this from being your entire window, and you can create kind of separate window panes, if you will. So in this context, to maybe just round that off, that explanation, it's a little bit complicated to understand. I have a playback event ID, and I have a start time for my event, and I have a key and a value. And what I want to do is I want to create a row number here that iterates on the entire data set. So the row number is incremental, it goes up automatically, but I wanted to only do it with this particular window pane at a time. So it will take the playback event ID, this one, and it will iterate. And when it gets to the end of this value, so it reaches here and it says, that's the end of my first window pane. Now I start at my next window pane, and for that I start my function again. My internet fell down. Oh no. I hope it wasn't as dramatic as I thought it was. Thank you for the explanation. You're most welcome. And if you need more explanation, feel free to ask more questions. Absolutely. It's a very complicated concept, actually. Especially in this framework here, it's a bit tricky to understand. If we had maybe more explainable data, it might be more straightforward. But yeah, I hope I did a good enough explanation. It also took me a long time to understand the window analogy. And I mean, it took me forever to understand that basically over is the window function, and everything else around it with like rank or row number or partition by and order by or leading and lagging, those are all just additional functionalities of the actual window function itself. But the window is actually just created by the over itself. So when you just write over, you've already done your window. It doesn't do anything, you need to tell it what to do. But yeah, that's... Yeah. I hope your internet is back up and stable, Algebra. In any case, we seem to have solved the issue. Now, if I create this table, there's actually a way to do this really elegantly. If you have a select statement and you have read-write access to your database, then you can actually just say into, and you can actually write a new table with the result. So we can do that right now because I have read-write access on my own database. And now we have this playback events stream. And we have all of this data here. And the really nice thing about this is that it's auto-adapting to the type of format that the column is in my final query. So here, like, this is a big int, for example, and this is the timestamp is text, for example. So if I actually wanted now to take this tsutc and make it a timestamp, that would be smart because it would allow me to keep the format in my table. So I'm going to just drop that one and just insert the table again. So now you see here, you see this is a timestamp. And so we don't have to go puffing about with different data types of these different columns. That being said, there's definitely some optimization that we can do. And the optimization we can do is we didn't take all the information from the playback events into this table. And the reason for that is redundancy. I would be storing the information multiple times in the same place. So like, for example, we have our first playback event, according to time anyway, is not this one. I think it's this one. So it's some kind of device, and there's a playback event. Okay, this one's not so good as an example. So this one is a title, and there's a playback event on this particular row, right? So the smart thing would be to actually take these timestamps as an identifier, assuming that they're unique, which I'm not sure is the case. So that's something we need to investigate, because then I could make these playback event IDs tie back to this table here, the main table. But I think that this timestamp will be unique enough because it's down to the second. But let's see if that's the case. So yeah, I just created this event ID just to have this in the table. Indigenous Navi. Maddie, can we just take a minute to talk about your IDE? I use VSCode. What are the benefits of using JetStreams rather than VSCode? Ooh, that's a loaded question. So look, basically, I have never worked with VSCode. I know several people who I work with quite closely who swear by VSCode. I was introduced to JetBrains some years ago, to DataGrip in particular. And honestly, for working with databases, so that means dropping tables, creating tables, finding out structural visualizations, like you can map the entire schema of a database and all this kind of cool stuff, as well as writing queries, it is, for me, the most comfortable solution. It doesn't mean that VS Code is bad. I myself have not tried it out, so I can't say whether it's better. What I can say is that DataGrip is very powerful. I'm currently running it within Docker, so it makes it a little bit more flexible. I mean, in the sense that DataGrip itself is just installed on my system, and I run Postgres within Docker, within a Docker container. That's why it's here on, well, it's not the reason it's in localhost, but that's why it's locally and not on some cloud server somewhere. And honestly, I love this setup. It's super fast. I can change things on the database instantly, right? I have all the power at my fingertips. The customization options of DataGrip are incredible. That being said, I think VS Code is also a good piece of software. Like, I haven't heard anything negative about it per se. I just, in the industry that I'm in, a lot of people do recommend using either PyCharm or DataGrip. So if you're working with Python and doing a lot of Python coding, then PyCharm is definitely a little bit of a better solution. Sorry, I just need to hydrate quickly. But yeah, so basically, to answer your question, I think DataGrip is nice. It doesn't mean that it's better than anything else. I use Postgres too. Thank you for the explanation. I really appreciate the info. Yeah, no problem. Like I said, this is a open learning environment. People should just ask what's on their mind. And I don't have all the answers, of course, but I like to see other people's opinions as well. Like, you know, if people bring in, oh, I've been using this and this solution, for example. Like, I also watch a few other streamers in the data space, and there's not many of us, to be very fair, but they use a completely different set of tools than I do, and it's always interesting to see how they work. So yeah, I have relatively chill music running today because it's Friday evening and I feel a little bit chill, but feel free to suggest other styles if you people would prefer something else. No problem, I'm open to that. So we were here at the timestamp. I think the timestamp is unique enough that we can use it as an identifier, but we need to figure that out. So we are going to start a new query console. This one is kind of like saved now as like the holy grail of fixing my event data. So I'm going to start a new one just to figure out if this timestamp is usable as an identifier. The way that I'm going to do that is just say I want to select from playback events, Oh, it doesn't like that yeah, so one thing about data group which is interesting, you can actually change schema on the fly. But if I haven't defined one by default, then it will ask me to have the schema in here. But you could technically avoid writing this Netflix usage part by denoting the schema that you're in here. Yeah, by just changing this over to Netflix usage. It's being cut off screen a little bit, but you get the idea. You guys are smart. And so what I want to do here, just remember the structure of our table. We have a profile, a blah, 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 and then we have this playback start UTC. First, what we do is we count how many rows do we have? That's the big question. Oh, we have 10,794 rows. And you saw how fast that was, right? 42 milliseconds. That is lightning. So locally is the way to go for smaller data sets. Definitely preferable to working in the cloud. I also don't need to pay for any servers running anywhere. Don't have any electricity costs other than my computer, which is running anyway. So, you know, I don't see any downside to doing this locally. When you start working with like 500 million rows or something, then okay, then we definitely talk about let's start bringing in AWS or BigQuery or something with like beefy guns, you know, to really power that stuff. So first thing, we have to figure out how many rows we have. We have 10,794 rows. Then what we do is we do count distinct of this timestamp, which is called playback start UTC. And we have 10,571. And this is the problem. It means that there are some that are not unique, which is an issue. So what we do is we basically say playback start UTC TS, count distinct, which gives me, or we can actually just do count star, which gives me basically number of rows. And then we group by 1, order by 2, descending. And then we get all the ones that are duplicated. And we see there's quite a few actually. Too many to handle. Too many to handle. Ah, that's unfortunate. Actually, would like to see the data itself, just to see how 223, yes, 223. Well, I mean, yes and no. It could be that like this one has 5 rows. So yeah, I mean, basically they have more than one row. These are the ones that are going to cause us a problem. So what I'm going to do is actually just look at, so all of these events took place at exactly the same timestamp. Wow, that's interesting, to say the least. I'm not really sure how, but it's possible. Oh, White Panther! So you have made it into my stream finally. Good to see you here. These 5... I'm only famous because you put me on your website. Otherwise I wouldn't be famous, you know. Oh dear. Well, what we have here is we have a timestamp that isn't unique in our dataset, which is a bit of an issue. So now we need to give it some kind of ID. So White Panther has been streaming before. I was briefly in her stream and then had to jump over to this one. And now it seems that the tables have turned. And I can highly recommend her stream. Really, really enjoyable and possibly the best overlays I've ever seen in my entire life, that's for sure. Very, very impressive stuff on there. I would say like somewhat adjacent to data. You're welcome. You're welcome, Panther. So yeah, we can't use this, which is really, really crappy. We can't use this as an identifier. We need to create one. So we are going to actually do this completely backwards. We have this playback event stream where we have an event ID. And what we're going to do is we're going to modify our query so that we actually do this with all of our play traces. So we don't want to exclude any of our data now. Because what we're going to do is we're going to assign all of these an event ID, and then we're going to do this the same way in the playback events table itself. So I need to drop my event stream table again to get rid of that. And then we're going to run this again. And now we have, we messed up something, guys. We messed up something. We have some kind of condition here. Okay, I should probably check this before inserting into a table again. So I'm gonna drop that again. Why are we missing our first event? Let's debug. Blah, blah, blah. Playback event ID, JSON array elements as play traces rows. Where is it going wrong? We start from the top. Started from the bottom, now I'm at the top. So it's here. I have a feeling about this one, people. I have a feeling. Select star from JSON. Don't harp on my namings, please. Please. Yeah. So because JSON array elements doesn't work on rows that don't have a JSON, we should probably pack this into a case when. So case when JSON array elements, I don't know, let's do the same condition we had before with length. Length of play traces JSON is greater than 2. Then we can do our normal play traces. Else, we need to output something else. What are we gonna output? I don't know, let's try something like this. Oh, really? Set returning functions are not allowed in case. Oh, this gets more complicated than I wanted. Oh boy. Boy. This is very unfortunate indeed. The main issue I'm facing is that actually, maybe this is actually okay, because if we do this in the same way for our existing table, so playback events, hold on a second. So if we do like this, for example, with playback events, then each of these will get an ID. And this one, let's take one at random, 449 has this timestamp. So in this table, 449 playback event ID equals 449. Is that the same one? It is. Okay. So this is not such an issue. Basically, our playback events stream doesn't contain all of our event IDs, which is normal because it only contains the ones that had aggregate information with it. So that's fine. So what we have is now our playback events table needs this event ID in it. Easiest way to do this. Easiest way to do this. We do this function here. So I don't advocate for doing this with production tables, but for our purposes, this is no problem. Oh, actually, I wanted these counts because we can check this in a second. So this is my table. And now what we can do is we can do our lovely into. So into Netflix usage, playback events. I'll just put a 2 so I don't overwrite my own table with the query. Haven't done that before, of course. Who do you think I am? Come on. Definitely haven't done that before. So now we have this playback events 2 table, and look at that, we have this playback event ID. And it looks to be correct. Let's take one at random. 235 has the timestamp 23rd of December, 7:38:18. And in the playback events stream, we'll do playback event ID equals, oh, now I already forgot it, 235. 23rd of December, 7:38:18. Yes, wonderful. So what we have achieved now is we have this playback events table. We can now drop our original table. I'm confident about that. I also have a backup, not to worry. I can rename this one to playback events. And now we have exactly what we wanted, which is, oh, we don't need to do this row number anymore, do we? We have a beautiful playback events table, which has, let's count again. So this is number of rows, right? 10,794 rows. And if we do count distinct playback event ID, we have 10,794 playback event IDs, which is exactly what we expect. And some timestamps will have more than one playback event ID, and that's why we have that event ID, so that we can be unique. But the best part is we can do this. Left join Netflix usage playback events stream ps dot playback event ID equals pe dot playback event ID. And basically what we can do with this is say, let's say limit 10. What I have now is for playback ID event 4, I have the entire split with all of the other dimensional data that we had before, so the title, etc. As an example, we can just say where playback event ID equals 235. That was the one we looked at earlier. So this playback event ID Bird Box trailer on the PS4 start. So the event happened at 7:38:18. The play traces don't interest us anymore. We're going to get to that in a second. And then I have again the start time, and then I have this array ID, the key, and the value. I see a potential issue. Only now. So one potential issue is that this event, while it has the same timestamp, these three occurred together. I mean, occurred together is probably the wrong word. These three belong together. So there isn't a way to partition them in a more clever way, is there? We can maybe go back to our code here. Now that we know that the playback events work, we can actually take the playback event ID from here. we don't even need to change it anymore. Oh yeah. Oopsies. Good that it warned me from doing that. So let's look at this example 235 because it's a good example. It has two distinct arrays in it. Sorry, array items. So 235, where playback event ID equals 235. Ideally, I would want these to be 1 and these to be 2, because I can always count rows. So if I wanted to do that, I would need to partition by array number. That could be interesting. I wonder if we can do that. Array position? But I don't think it's an actual array. Hold on. Let's call this JS. So okay, I don't want to mess up my query there, so I'm just going to make a new one. JSON. Array position JSON doesn't exist. This is quite tricky, so I would like to find out. Probably won't let me do length either. JSON array length. Okay, so this is just the length of the array itself. To the Googles we go. Array index, array item index, Postgres. So let's take a look. Array item number. This index is getting confused. Array size or number of dimensions. Number of dimensions. The current implementation does not enforce the declared number of dimensions. Yeah. But if it's called number of dimensions, then we shall call it array number of dimensions Postgres. To avoid confusion, slice syntax, array ndims. Oh, that could be something. Oh, okay, it's JSON, so it's not allowing us to do that, of course, because we need to do it further up with the but actually it hasn't been split here yet. Confusing. Let's try from JSON parsing. We might have to just do it one level earlier. No, doesn't like it on JSON because we converted that to JSON. JSON number of dimensions. JSON object index. Because there is JSON B as well. Index for finding an element in a JSON array. I'm not interested in indexing. If anyone knows the magic function to get the number of the array, that would be super cool. Basically, I'd like to have a number here in this final column. Like, this is all the same playback event. Let's just do the where conditions so it's easier. Oh, I forgot the equals. This is all the same playback event. You see it has 2, so I would want to have a 1 and a 2. Maybe I need to actually do a row number. Oh, even before? That might work. Okay, let's try this. So if we do... Because I think row number is applied at the end. That was the problem we were having before. But let's see. Row number over partition by playback event ID as array num. CJ, hello. I don't know the answer, but it's basically enumerate in Python. Yes. Enumerate array Postgres. Could be loop through arrays. The thing is, I don't want to iterate through it. Iterate over. Build a JSON object out of argument list. Let's see here. Key path. No. Get array element. 2. Do. This is quite nice. Accessors. Functions. Strip nulls, array to JSON. Of iterating and saving the position and value. Technically would work. I just want to avoid writing a function because I'm actually not very familiar with writing a function in SQL. It's something I've been avoiding, to be very honest with you. Because until now I've managed without it. I mean, I'm familiar with the idea of a function because I can write JavaScript, but declaring it and stuff in SQL is a bit different. So I haven't really invested too much time into that until now. Oh, maybe I don't need to partition. What the? Oh, right. Yeah. So it has partition by... Yeah, the issue is we can't partition by event ID, because of course each of these will receive a 1. Ah, wait. What if we rank? What if we rank without ties? Ah, what was the thing for that? I have to look this up. It was Postgres rank without ties. So basically rank, dense rank, that's right. Basically rank automatically ties them. But if you do dense rank, really? This should not equate them. Playback. Playback Event ID? Why is that not working? Window does not exist. Huh? You crazy? Of course it exists. Uh-oh, that's not good. Oh boy, this is really... I mean, it's a small thing, really. I'm actually like, I'm legitimately nitpicking, but these are sequential. I mean, I know that the event type denotes each new kind of grouping, but it just, in analysis, I think it's going to be more annoying somehow. I don't know. Maybe it doesn't matter so much. Don't want to spend too much time doing weird formatty stuff today. I kind of just wanted to get into it, you know. So I think we'll leave it, but it's a problem for another day, for sure. I will think a little bit more about that. But CJ, your suggestion of iterating would definitely work. There must be a function that allows you to get basically the kind of, how do you call this? The n number, right? JSON object aggregation? JSON out? No. Oh, actually, just had a silly idea. What if we count? So if we do JSON length, JSON array length, play traces JSON as array len. This song's a bit creepy, eh? I think I'm gonna change that one. It's a bit creepy. Star from JSON. Okay, we need to add the where again. Forgot. Playback Event ID equals 235. Okay, so the array length is 2. That's fine. But if... That's crazy. So it is JSON array. It knows how to do this. It knows how to do that. So JSON array. I'm actually curious if there's a way to sort of count. Probably not. In any case, let's leave it there for today. Let's leave it there. I much prefer to do the actual analysis part. So to remind everyone of the questions, because I think it is good to just toggle back to that quickly. The questions were, you know, what is our average watch time together versus separately? Now, in order to actually figure this out, there's a couple of steps required. And that is, so we have one playback event. Okay, fine. So we know when things happened. Do we actually have more information about the actual time that something is watched? Let's see if we can do that for one particular title. So this is where the analytical part comes in. So CJ says, yeah, the array index, I feel like there should definitely be a built-in function for it. I'm still learning SQL, but you're basically parsing a JSON. I came in a little late. You might be able to use the unnest to facilitate. Gotta run, but I'll check out some VODs. Glad to hear that, that you're learning SQL, and thanks for joining in today. Yeah, the previous VODs are all up on YouTube, the ones that have since expired on Twitch, but most of the last, I think, 2 weeks are still on Twitch. And yeah, in terms of unnest, that might actually do something. I know from BigQuery that unnest is a thing. You might be able to like sort of count it that way. It's worth writing down so I can at least remember later that you mentioned it. So thanks a lot for that suggestion. Yeah, it's because it's a JSON and not an array. It's basically an array of JSON objects. Or it's a JSON of JSON individual objects. I don't even know the right terminology for this one. But yeah, thanks for the suggestion. Definitely. And I saw that you actually followed yesterday, so thanks also for the follow. Anywho, unnest could be used as an intermediary step. My experience from BigQuery with unnest. Yeah. Hope to catch you live again soon. Yeah, I should be live on Monday again. I think we'll be doing something else though than analyzing our Netflix behavior. But who knows? You never know. I would like to figure out what our watch time is. And for that, we're going to take one particular event for one particular title. I don't think this is the best one, to be honest. I'm going to take something I am reasonably certain I actually watched. So let's say, I don't know. Here we go. Marvel Daredevil. Season 3. No Good Deed. There we go. Now you can see actually that these here are all duplicated. And the reason for that is of course because all of the columns here are split out. Now the easiest way to look at this data would be to clean this up a little bit. So we have our pe.playback event ID. We have our pe profile name. We can actually make a little case when here, but that's fine. pe.title description. That's a very advanced title, basically. Device. Country is not so important right now. It's always going to be Switzerland, just for reference. Maybe when we watch something, I don't know if we're on holiday or something, but that's not so important. The playback start time is important, but we have it in the other table now. So we don't need the play traces. So now we have the ps dot playback start tsutc, which is a timestamp. The ps event array ID, which is not an array ID, but okay. And then we have the ps.key and ps.value. Voila. I'm going to take this into away because it's dangerous. And this is our final data set to work with now. I could probably ignore device for the moment because it's not that important. So there we go. We have our playback event ID. What's interesting is some of these are not in here. So this should be the full playback events. I should have everything. Yeah, I have all of them. I'm expecting, well, let's order by 1 descending. No, sorry, it's ascending. I keep forgetting. There we go. Ah, here we go. So the playback start TS is null because it's not joinable. Ah, okay. So maybe we'll do it like this. pe.playback start UTC is playback start UTC, and we will cast this to timestamp. I just don't want these to be null in my data set. Voila. So that is that. Good. Now we figure out, how do we calculate watch time? That is a bit more complicated. For that, we would actually have to take apart Netflix's data model. The nice thing is we don't need to do that because we can interpret it. And we can interpret it by looking at the events and the so-called session offset or media offset. The session offset, from my understanding, is when they calculate the duration of an actual watch session, and the media offset is the interaction timestamp of the individual media events. So you have the playback start, and so if you take media offset milliseconds 3000 and you do 3000 divided by 100, then you get 30 seconds. So 30 seconds after I paused, basically. So that's how we would calculate watch time, basically. And for that, we will have to use one event in particular. So let's go look for that one. Where was it? There was one with Daredevil here. Here we go. So Marvel's Daredevil Season 3 Blindsided. This is the one we want. Playback Event ID 47. Playback Event ID equals 47. There we go. So we had to use the prefix here, by the way, because this ID exists in both tables. We have to say which one that we want. So nice clean data, right? What do we want from this? So this is like, let's call this like data frame. It's not the right terminology, but I'm just using an alias here. It's not a big deal. So we have our data frame. This has everything in it that we want. Now we can select from our data frame. DF. And what are we going to select here? We are going to select primarily, first of all, the playback event ID, which is just to have it in there. And we're going to have the key and the value. And I'm going to make another where condition because I want to start exploring these keys. So I want to say where key in, and I can make different ones, event type, and media offset ms. So now we start to get the thing that we need. You need, so to make this a little bit bigger, we have basically event type start, media offset 0, event type playing, media 0, paused, 2252, playing. So these are all pings, right? Paused, playing, paused, playing, paused, etc. This is the sequence of this particular event. Let's not forget, this has a playback start time, which is the same. This is when playback started. So if I take stopped, this value in milliseconds of media offset of the last stopped event would be the watch time, logically. Question is, how do we get the last stopped? Well, first we look for okay, so we have to do a bit of a mixed condition here. And value is stopped. or value like any number, right? So like greater than 0. Sorry, just value greater than 0. Oh, it's not a int. What's happening here? Invalid input syntax for type integer. Ah, yeah, we can't cast it. Of course not. Okay. This is just a filtering problem. Well, in this data set, we could actually just do a sort of lag function. Basically, lag over partition. Do we need an order? Oh, I need to look up lag. I don't remember. Postgres lag. Basically, I want to get one row after, because after the event type stopped is the media offset. Lag expression offset blah blah blah. Give me an example. Lag amount 1. Really? Amount? Aha, right, the key. So it would be lag, I don't know, playback event ID 1 over, and we'll call this media offset. No, that didn't work. It would be value. Brain fart moment. Okay, so... Wait, what? Oh, it's done the other way. Yeah, so basically here, the value for stopped is, because we have always the same sequence and the same order, because of the way the data is collected, we now have the time for the offset, which is pretty nice, but we can't take out media offset. This doesn't work if you do it that way. So we're going to do media offset ms divided by 100.0. So we'll do lag blah 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 over. Maybe we wrap this in a bracket. And this is media offset in seconds. Oh yeah, it doesn't like this. Int. Oh man. Because sometimes, of course, it's just taking the next event type in the media offset. Oh, well, you know what? We can do... Let's do... It would be too complicated, but I guess we can do it. Case when e equals event type, then lead value over blah 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 end. Ooh, there we go. Honestly, was it worth it? Kind of. So divided by 100, divided by 60, and this is in minutes. Wow. 523 minutes? That seems absurdly long. It's 8 hours. It's in milliseconds, so 100 milliseconds is a second. 60 seconds to a minute. Yeah. Or am I doing math wrong, chat? Like, seems a bit odd. I suppose it's possible, but how did I watch 8 hours of stuff? Maybe it's not doing this sequentially. Let's just keep it in seconds. So we have 31,415 seconds divided by 60 is 523 minutes. Yeah. Honestly, that's the problem. Basic math issues, right? "52 minutes. Now, of course, we could leave this in seconds and do the calculation later, which would make more sense, to be honest. So we'll do time. We need second. Millisecond is 1000. Yep. So 1000 is now seconds. All right. So it's 3141 seconds, which is divided by 60 is 52 minutes. Correct. All right. So we now have a media offset for each stopped event. So what we can do is we can say, let's call this stopped events. So we have stopped events table. What we can do is to select star from data frame, left join, stopped events, se dot playback event ID equals df dot playback event ID. See how important it was to create this event ID? Like, super crucial. And I leaned in to say that because I cannot emphasize that enough. What do we get if we take this? We get basically the whole shebang. And so what we do is we can now, actually within this thing, we could actually rank them. It's maybe a cool idea. So if we were to actually rank each of these rows, I suppose it's not that helpful. So there's a thing to do here. Basically, if you want to only take some stopped events, you could do a where clause down here underneath your select. But what you can also do is make a little select here so that you only take the ones that you want. So select star from stop events where key equals start. Oh, we want in. Or do we need the start? I don't think we need the start. We just need the stopped. And then we have basically for this 47, wow, really? Oh, it's not the key, it's the value. My bad. So you see you have this stop value. And what we can do is, instead of blowing up this entire thing, we can now abstract it into one row. So we have the Playback Event ID, and then we have the min or max, it doesn't really matter at this point. The max SE media offset. Oh, did we forget a group by chat? Did we do that? Voila. So this is the max. Well, if we just take the media offset, there should only be one row, technically. Yeah, we can just do distinct instead of doing an aggregate function. That also works. So we now have the play time duration, right? Because the way that we did this is like we counted when things are stopped. It's maybe not 100% precise because we didn't account for all the pauses in between, but that gets pretty complicated. I mean, let's just do the simple version first. Seeing as it is 90 minutes into the stream, we should start doing some kind of analysis work. So we now have, for this particular one playback event ID, we have the media offset. So technically, if I take this where condition out, we should have it for everything. Hell yeah. Oh, some of them don't have, which is fine. So this is playtime seconds. And let's do order by 1. There we go. So the ones that don't have playtime, we'll just take them out. So now we have the playback, we have the event IDs, so we have playback values. Oops. Weird formatting stuff. So we have the playback values. What else do we need to include in here, chat? I think we should include the profile stuff. That's the profile. Oh yeah, I didn't do a select down here. So you see what's happening here? Now we have all the playtime. What do we do now? Easy peasy. We do profile sum playtime seconds. And this is the total watch time. Ah, of course. You could almost say I did it on purpose. There we go. These are the watch times. Now it's not so nice because it's in seconds, so we're going to divide by 60. And this is total watch time minutes. So if we do 3600, it's hours, right? Let's do a quick check. So if I have second and I want to go to hours, oh no, 1 hour is how many seconds? 3600, yeah, wonderful. There's the watch time in hours. And the answer to our question, the question was, what is our average watch time together versus separately? Well, this is total watch time, but yeah, we can look at the average in a second. The total watch time is larger individually than it is together. So that is the answer to that question. Total watch time individually is larger than together. The hypothesis was that we watch longer when we're together, so the hypothesis is wrong. False. Disproven. That being said, does that surprise you, by the way, chat? I mean, if you have Netflix with your partner or you share it with some other people, do you think it's surprising that you, when you watch together, maybe your profiles are not split like ours, but does it surprise you that individual watch time is higher than watch time together? I guess looking back, it makes sense because you have two dependencies. Both people have to have time to watch something if you want to watch together. But what we can do is we can take this entire rigmarole and we can do the same thing, but maybe we don't need to do it that way. We could do technically and figure out maybe there's a difference in averages over a point in time. So for that, in the playback values, we have this df.playback timestamp of some kind. Yeah, playback start UTC. So this is a timestamp. So what we're going to do is extract, or hold on, let's do timestamp trunk instead. Is it called trunk? I thought it was timestamp trunk. Postgres timestamp trunk. Date trunk. Oh right, yeah, you can use date trunk as well. Oh yeah, true. So you just do date trunk text timestamp. So we do like this as playback month. So let's do some interesting analysis here. I'm going to truncate everything to month. Oh, I need to put single quotes in that. So now we have to include the playback month in here, grouped by 1 and 2. Now we have each month. We could just format this as a date. All right, so now we have each month. If we didn't use Netflix for a while, it might be the case that one of our profiles doesn't have a date, so that's a bit of an issue. But we could somehow work out if the monthly average, this is kind of what I meant about the watch time, maybe the monthly average is higher in some cases than the others. So what we'll do, we're going to do something easy. Case when profile is m plus m, then together when profile equals then then alone. I wanted to summarize them together. Maybe that's not the best. Let's try it this way first. Else kids and profile type. There we go. I like these rainbow tab things because you can really see if everything is aligned. So what we have is basically alone and together, and now we can order things so that it always has the same format. And so there might be some months missing, but I doubt it. I think we always use Netflix at least once a month. 'Cause So I don't think there's any missing. 9, 10, 11, 12, 1. Kids, okay, together. January, February, March, April, May. I could do like a generate series here and make sure that I have all of them, but I'm just doing a quick check. Yeah. So the total watch time in hours per month is very different because now it's an average. So this is the average watch time in hours. I think we'll round this. Doesn't make any sense to have so many. So many decimals. So now we have each value per month. Now we can figure out, is this average watch time per month different than the overall average? If that makes sense. So basically we have like our profile and the month of when we play back. And then we could do here. I want to do an over. So I want to do an average of the playtime seconds. Actually, I want this here, the same thing as this. I want this, but I want it to be partitioned. So over the profile type itself. Oh, I don't think I have that available here. So actually we have to do this in a second statement. So we'll do playback values and then we'll call this aggregates, because it's the last one. Aggregates as select star from aggregates, and we do round the average playtime in seconds don't have it available to us. Oh, that's a bit tricky. Maybe we'll just do both the aggregations in the same frame. Then we don't need to do a group by. That could work. So we have the average watch time in hours, average monthly hours watched. And then we have here average hours watched. Over specified but round is not a window function. We might have to round it later. Does that work? No. Group by 1, 2, 3. Oh, we don't need the playtime. Sorry. Just profile type and playback month. Then we just do order by group by 1 and 2. But the playtime, it wants it to be aggregated because because... Ah, I see. Ah, then playtime in minutes, hours. So then we just take round average playtime hours. Oh, it doesn't like this at all. Let's do the rounding later. Yeah, it doesn't like it because it's a bit of a grouping issue. But basically, we should definitely float this. Or like that. There we go. We could round this to 2 decimals. I'm not sure if you can round with the over function. No. That's fine. We will round it afterwards. But basically, this is the average hours watched. Partition by profile type. So the average hours watched is now split per profile type. So like profile alone is 364. There's way too many rows here. 1 second. I think there's an issue. Ah, yeah, it's because of this. It's really, I'm not sure why this is causing such problems. So we have a playtime value. What if we don't do an average with it? So we do playtime hours and then playtime hours over blah blah blah. That's not going to do anything, right? Average playtime hours group by 1, 2. No, it still doesn't like that because it wants playtime hours to be grouped in the first place, which is super annoying because it's an aggregate. So what we can do is just do that's a tricky one. So if this makes sense, let's just look at this for a second. Basically, we have each profile with each month with playtime hours. Oh, I see. It's already a problem here because the playtime hours are not summed. Ah. Here we go. Problem solved. Now you have the the total playtime hours per month. So if we have then the profile type, the playback month, and then the average playtime hours. Oh, it still doesn't like this. Let me see this. All right, so we have the average playtime hours for each profile. So for kids, it's 20. For alone, it's 36. And together, it's 12. This already tells us the answer to our question. The average per month is actually higher individually, 3 times higher than together. That's the answer. Of course, we didn't need to include the month in this. Could have just done it like this. So not only the total, but also the average. What I wanted to see is in which months it's below and above average. But looking at the time, I think it was an ambitious stream that we tried to do all 3 questions. Yeah, it was pretty ambitious to answer all of these. But that being said, I think this has been answered, which I think is pretty cool. Do we watch more TVs than movies? We have to see if we can actually differentiate them in the data set, because I'm not really sure that's possible. Are there any common shows that we watch separately we could watch together? That one also requires some title parsing, but not so much with the watch time. But yeah, definitely... Oh, sorry about that. Definitely very interesting working with this data set. I don't know if anyone else is interested in the Netflix data, but you can just go to Netflix's website, log in, and there is a process that will direct you to like a GDPR request. You can just Google it, and you should be able to find it. So yeah, I think I'm quite happy with the end result, even though it was a bit arduous. I think there's a lot more to be had from that data, for sure. But I feel like we just scratched the surface. Also, with all those event information, I would like to spend a bit more time probably looking at the different types of events that there are with the different values. But I think we're gonna call that a day for now. I hope you've enjoyed the stream on a Friday versus a Saturday. It's also a bit different, but we will be back on Monday again with a stream. I don't think we'll be looking at the Netflix data. It kind of depends on what I feel like doing. If we want to continue where we left off, we may look at something else. I definitely have enough ideas kicking around. With that being said, I hope you have a wonderful evening, weekend, afternoon, morning, whatever time it is for you, and hope to see you again next time. Thanks and bye-bye.